Hello, this is chapter 2, using computer data. Last week, or last chapter, we looked at uh, how bytes are formed using 8 bits, and now we're going to take that information and show how it's used in different fashions. So we're going to start off looking at some encryption models that deal with something called bit shifting and then nibble swapping. Remember, from the previous chapter, we looked at nibbles. That's 4 bits of information. So each byte has 2 nibbles. So some other uses besides encryption will also be file headers and hashing, and we'll talk about that in later on. But for right now, we're going to talk about encryption, which is a process of changing or obfuscating data in some encoding method. Um, Typically uses some type of mathematical formula, but this can be, again, at a bit level, at the nibble level, or at the byte level. And so we're going to walk through some of these different methods. So bit shifting, the process of moving bits either to the right or the left. Nibble swapping is a process that switches to the order of the 2 nibbles within a byte. And then we're going to, later lecture, we're going to talk about something called XORing at the bit level. Okay, so bit shifting. We're going to first talk about non-looping. So that just means that we're going to drop some bits off. So this will make more sense as we start going through this, because I know I'm just rambling at this point. But if we look at this byte of information, originally it's decimal 70, or the letter F in the ASCII table. And again, we get 70 by adding 64, 4, and 2, any of those columns that have a 1 in it. So we've got 0, 1, 0, 0, 0, 1, 1, 0. And we want to alter this or encrypt this information. So we're going to do a bit shift. So in this case, we're going to shift 1 bit to the left. Okay. So again, I'm going to flip back here. Remember, if you look at this, originally the most left bit under 128 is a 0. We're now shifting each one to the left, and that 0 is just going to drop off. And we're going to add a 0 onto the right-hand side. So now our new value is decimal 140, and that little I with a caret over the top of it in the ASCII table. So we've just encrypted our data from that F, capital F, to this I with a caret on it. I'm sure it has a name, but I have no idea what that is. So this is a very rudimentary encryption method. Okay. If we could do the same thing, we could shift 2 bits to the right. So if we take that same value that we had previously and we shift it to the right, we now get decimal 30. So we start at 122 and we shift to the right 2 bits, and we now get decimal 30. Okay, so which is the right shift key. So we're going from a lowercase z to the right shift key by shifting that way. Okay. Now, so that again is considered a non-loop because we just drop off any of those bits as we move either to the left or the right. Another scheme is called looping bit shift. In this case, so if we go to the left 2 characters, those 2 characters loop around and end up on the right side. So again, we're going to look at this. You'll see we're at 1, 1, 0, 0, 1, 1, 0, 0. So I'm going to do 2 shifts to the left. And you see that those ones that were previously on the left-hand side, the 1, 1 under 128, 1, 6, and 64, are now under the 2 and the 1. And we've shifted everything over. So we went from 204 decimal, which is that little graphic character, to decimal 51, which is the number 3. Okay. All right, so that's doing it 1 or 2 bits at a time. Now we're also going to talk about taking an entire nibble. Remember, that's 4 bits, and we're going to swap the order. So in this case, we're going to start with this value of a lowercase x which is decimal 88. And so you see we have 0101 and then 1000 as our two nibbles. Okay. Hexadecimally, that's 5 hex, and 8 hex or 58 hex. And now we're going to swap the positions. And so now we go from with an 8 hex to a 5 hex for your two nibbles. If you calculate out the decimal value, it's 133, and that's the capital A with that little slash above it. So again, we're encrypting from a lowercase x to this different character by just swapping the nibbles. Okay. This isn't real high-level encryption, and this would be fairly easy to crack, but it is a rudimentary way of hiding information.